Alright guys, this was a test about graphing rational functions. This is part 1 of the lesson. In this video we will focus on analyzing this graph that we're given and finding out what are the maxima and minima, what are the asymptotes, end behavior, increasing and decreasing intervals, all that good stuff. So let's start with the horizontal asymptote. The horizontal asymptote depends on the degree. If the numerator degree is less than the denominator, then it's y equals 0. If the numerator degree is the same as the degree of the denominator, then the horizontal asymptote is y equals a over c, where a and c are the leading coefficients of their little polynomials. Now, if the degree of the numerator is greater than that of the denominator, there is no horizontal asymptote. So let's look back and see which one of those situations we're in. Oh look, the degree of the numerator is 2. The denominator is only 1. So since the degree of the numerator is greater, there is no horizontal asymptote. Okay? However, if the degree of the numerator is 1 more than the denominator, usually there is a slant asymptote. Okay, so you never will have both, so that's why we could put them on the same line, because either you might have a horizontal asymptote or a slant asymptote, but never both at the same time. So let's see what the slant asymptote is. To find that out, you do division, like either long division or synthetic. Since it's just a nice simple x plus 1, let's go for a synthetic division. So in the little synthetic division box, we put -1, all right, it's like the opposite of this, and then the coefficients. Here we have -1, and then 4, and then 2. And then we skip a line, the remainder goes in this little box at the end. Okay, so we bring this first one down and we multiply, so that'll make +1, and we add, so that'll make 5, and then we multiply, and that's -5, and then we add, so that's -3. Okay, if we put the variables back in, then what we have is -x plus 5. Okay, so we have f of x equals -x plus 5, and then the remainder is like this, plus -3 over x plus 1. Alright, so this is known as the quotient form of the rational function, but the part that I've left here in pink, this is the slant asymptote. Alright, it's the quotient form without the remainder, so -x plus 5. So that's why for the slant asymptote, we're going to put y equals -x plus 5. Okay, now we're going to graph this. Well, actually, maybe we don't have to graph it. We don't have to graph it. We just had to say what it is. So that's fine. Let's move on. Now let's talk about the vertical asymptote. You will get the vertical asymptote by setting this denominator equal to 0 and solving it. So if I do that, then I've got x plus 1 equals 0, subtract 1 on both sides, that gives me x equals -1. That's how you find a vertical asymptote. Okay, so x equals -1. Make sure you put x equals, don't just put -1. Don't just put -x plus 5, put y equals -5. Now let's talk about the domain. Oh, the vertical asymptote. I think I will go ahead and draw that vertical asymptote. Alright, it's at -1. Alright, I'm drawing the vertical asymptote because it gets involved with the domain. Alright, the domain is the x values of a graph. So we're reading the graph from left to right, and most polynomials, if it was a polynomial, it would just be -infinity to +infinity. But this rational function has an asymptote right here. That means there are no x values at -1. All right, see, it comes right up to the -1 and then it skips over -1, and then it sort of continues from there. So when we do the domain, we're going to have to say -infinity to -1, and then we'll have to do another part that starts at 1 and goes to positive infinity. Okay, so that's why the domain is going to be -infinity to -1. All right, that -1 is the asymptote. And then union -1 to positive infinity. Now, you know that the graph approaches the asymptote but never touches it. Okay, that's why we leave it as a rounded parenthesis instead of making a square bracket. Okay, so there is your domain. Now the range. So when we talk about the range, we're switching from x values to y values. All right, the range is the y values. Now, so we have to give it from bottom to top, from least to greatest. So again, these y values start down here at -infinity. Okay, so my range is going to start here at -infinity. Okay, now I have y values, y values, y values until I get to here. All right, I have no y values for a while, so there's going to be a gap in my y values. So what is this highest y value right here? Well, that's the 2.5 that's right here. So I will say -infinity to 2.5. Okay, that's the bottom until the local maximum there. And then there's a gap, so I'll just put union. And then it picks up again right here. Okay, what's the y value of this spot? 9.5. So we will pick up from 9.5 and we will go on to positive infinity. Now, I made a small mistake right here. I'm going to fix that now. This 2.5 and this 9.5, these are not asymptotes. All right, the graph hits this value. All right, the graph reaches 2.5. The graph reaches 9.5. So I won't use parentheses here. I'm going to use square brackets to show that 2.5 is part of the range. Right, it's included. Okay, now let's talk relative max. All right, the relative max is if you see a hill, it'll be the top of that little hill, even if it's not the highest point on the whole graph. So I'm hoping you can see that this spot right here is the top of this hill. All right, that makes it the relative max, or the local max. So I'm just going to write down this whole point. All right, this is 0.7 comma 2.5. All right, that is the relative max, or the local max. Now the relative min is going to be the bottom of a valley. Okay, so right here, this is the bottom of this valley. It is not the lowest point on the whole graph, but it's at the bottom of a valley. All right, so that's, I'm just going to write down this point. So the relative min is -2.7 comma 9.5. Now, the absolute max would be the highest point on the whole graph, but this graph goes up forever. Okay, if you look at your range, you see that it goes up to positive infinity, so there is no absolute max. So we will put none. Similarly, there is no absolute min either. All right, this graph goes down forever. All right, you can see that because your range starts at -infinity. So there will be no absolute min either. Now, it's time for the increasing and decreasing intervals. So we will read this from left to right. Increasing and decreasing intervals are strictly x values. So if we start here on the left, at first this graph is decreasing. All right, because you can see that's going down, 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 down. It's going downhill right until it gets to the bottom. Okay, so this pink zone is a decreasing interval. Now let's talk about the x values of this. All right, on this end over here, the x value is negative infinity. Okay? Some kids think it's going to be positive infinity because it's going up, but that's a y value if you say up. I'm putting negative infinity because this goes to the left forever. Now, the x value of the other end is negative 2.7. Okay, it's right there. So from negative infinity to negative 2.7, the graph is decreasing. Okay, so that's my first one of these. So negative infinity to negative 2.7. Okay, now let's see what happens next. As we continue on, the graph begins increasing. So it's like this. Now again, we're doing x values, okay? So this begins to increase right at this x value. And again, it's negative 2.7. Now, how far does this green interval go to the right? Does it go to the right forever? All right, do I put positive infinity? No. It runs into this brick wall right here. It runs into the asymptote, and it just approaches the asymptote. So this little increasing part of the graph starts at an x value of negative 2.7, and then it goes all the way over to negative 1. But it doesn't go past the asymptote. So negative 2.7 to negative 1. Notice that increasing and decreasing intervals always use parentheses. Okay, that's because notice the negative 2.7, for example. That was the last number mentioned in the decreasing interval, and it's the first number mentioned in the increasing interval. All right, but right at negative 2.7, it's neither increasing nor decreasing. It's right at the bottom. It's a 1 point of flatness. Okay, so we cannot include the endpoints in the increasing and decreasing, so we leave it round. Okay, what happens next? We jump over the asymptote. So we have to start from here. So this graph is now increasing, okay, from here to here. Okay, it's rising. From left to right, it's increasing. Now, it's picking right up from the asymptote. So this starting from this value of negative 1, x value of negative 1, the asymptote, and it's ending at this x value right here. Okay, what's this x value? Well, that's your 0.7. Okay, so this increasing interval is going from negative 1 to 0.7. So union, negative 1 to 0.7. So let's see what happens next. All right, well then the function goes back to decreasing again. Okay, so still we're starting this off at an x value of 0.7. And what's the x value right here? Positive infinity. If you were thinking negative infinity, you were probably looking at the fact that it goes down. But that's y values when you say down. All right, from left to right, it's going from 0.7 to positive infinity. Okay, so that's another decreasing interval. So 0.7 to infinity. So there's your increasing and decreasing intervals. Last but not least, let's talk about the end behavior. All right, now look, it doesn't matter what's going on in the middle of the graph here. All that matters is what's happening on the end. All right, let me erase this because that's misleading. Okay, so switch your brain. For end behavior, we're back to thinking about y values again. So on the left, what's happening to this graph? Is it rising forever? Is it falling? Is it approaching an asymptote? What? Yeah, looking at the y value of it, on this end it's going up, 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 up forever. So that's why on the left, okay, this is the left end. Let me just tone this down a little bit. Okay, So that's why on the left end we will have positive infinity, because this means this would be read as x approaches negative infinity, f of x approaches what? But this means as the x values go to the left, the y values go up. Okay? Now, so let's find out what happens as the x values go to the right. So now we're looking at this end for our end behavior. Now, as the x values go to the right, this function is going down, down, down. Okay, so that's why this end behavior will be negative infinity. Okay, now, even though this is only one problem, there's a lot to it. So this is actually long enough for a video. So I'm going to end this video here, and I will see you. We'll pick up with number 2 on the next video. Okay? And problem number 2, you won't be given a graph, but yet you'll need to figure out the asymptotes and the holes.